Hello everyone, welcome to your 6-4 lesson on geometric sequences. Our learning target for today, we are going to be able to identify and describe geometric sequences. We will be able to find explicit and recursive formulas for geometric sequences. We'll translate between recursive and explicit formulas for geometric sequences, and we're going to be able to construct exponential functions to represent geometric sequences. All right, so what is a geometric sequence? That was all over the learning target. It's what the lesson is on. So let's put in some definitions into our notes. All right, so that geometric sequence is a number sequence in which each term after the first term is found by multiplying the previous term by a common ratio. So let me just give you an example of what a geometric sequence looks like. Let's say the first term is 1 and the common ratio is 2. So I'm going to multiply the previous term by 2. 1 times 2 is 2. Now I multiply the previous term by 2 again and we get 4. Multiply the previous term of 4 by 2 and we get 8. Multiply the previous term by 2. Multiply the previous term by 2. And you see we could continue this pattern forever. So that's what a geometric sequence looks like. Just to remind you, you guys have seen arithmetic sequence before. That's where instead of multiplying to get to the next term, you guys were adding what we call a common difference to get to the next term. So geometric uses multiplication. We're going to see two forms of geometric sequences. This first form is called an explicit formula. A sub n, that's a subscript, so a sub n equals a sub 1 times r raised to the n minus 1 power. Let's define what all that means. A sub n is the nth term. So if I said a sub 5, that would be the 5th term. A sub 20 is the 20th term. This a sub 1 is the first term of the sequence. And then the r is the common ratio. So that's the structure of an explicit formula. You also could write a geometric sequence with a recursive formula. So it's kind of like, you guys know about equations of lines. You can write it in slope-intercept form. You could write it in point-slope form. You could write it in standard form. All of those forms are equations for the same line. So this formula, explicit, and the recursive formula we're about to write in are just formulas for the same sequence, whatever our geometric sequence may be. Okay, so what is the structure of a recursive formula? A sub n equals r times a sub n minus 1. And then we're going to add on with a sub 1 equal to something. So when you write a recursive formula, basically you are just telling everyone what to do to the previous term. So let's define the different parts of this and then we'll just talk about how it works. So a sub n is the nth term. We've got that r, that's our common ratio. And then the easiest way to think about that a sub n minus 1, think about that as being the previous term. So you have to give everyone a starting point. So we say with a sub 1 equal, and we fill in whatever the first term is. If we were writing a formula for this sequence up here, we would say with a sub 1 equal to, and we would write a 1 right there. Then what we do is then people would follow the rule. So you'd say, oh, take your common ratio and multiply it by the previous term. That would get you the next term. Then take the common ratio, multiply it by this previous term. Then take the common ratio, multiply it by this previous term. So you're basically just telling everyone how to get the next term in the sequence with a recursive formula.